So, hi students. This topic we have already given a brief of gradient descent optimization algorithm, but I am again teaching this, or this video I have shared only because this particular topic, optimization algorithm, like gradient descent, everything, RMS prop, momentum, etc., are very important. So from this figure you understood that a neural network is there. From there the output is predicted output, and the loss function is going to calculate it as the error between predicted output and the ground truth. Okay, so then after that, in optimization algorithm, what we are going to do, we will calculate the gradient, and thereby we are updating the parameters, sorry, weights. Okay, so the error or loss function is calculated as y predicted minus y actual. What is y predicted? Output. Predicted output minus actual output. So gradient descent is an optimization algorithm that will gradually minimize. The role or the goal of optimization algorithm is to minimize the objective function, loss function, error function. All these three terms are synonymous. So the f of x, somewhere it is written j of w is the weights, f of x is the weights. So, and through several iterations we are going to achieve the optimization. Optimization means what? We are going to achieve the global minimum. So, with what are the two goals of optimization algorithms? We have two goals. Either if we are talking about a convex function means that loss function, that particular loss function or objective function is convex, then there is a global minimum. We need to reach, or we need to minimize the objective function into that global minimum. If it is a non-convex function, then there will be a local minimum and the global minimum. So the ultimate goal is to reach the global minimum, but sometimes it may trap in the local minimum. So this convex function and non-convex function I am talking about, you should picturize in your mind what is a convex function and a non-convex function. So the first figure is the convex function. Don't forget that if you are explaining, or if the question comes for the optimization algorithm, in that optimization algorithm answer that you are going to uh, try to answer, in that it should be figures, there should be equations, and there should be everything marked. Okay, and a well detailed explanation. Okay, so in that convex function, in that this is the convex function for both. So the current position means the loss function is there in the current position, and we need to reach at the minima. Okay, so how will we reach to the minima? By taking smaller steps, right? From the current position to the minima, we need to take very smaller steps. And that steps, incremental steps, are called as what? Learning rate. Okay, so in this figure, it is clearly mentioned. This figure is very, very important. We have a black dot, that is the gradient descent, right? This is the this is the initial step, initial position of your cost function. From here to here it has to reach, this is the global minimum, that is minimum cost, by taking incremental step. These are steps are called as learning rate, and this function is the derivative of the cost function. Okay, the convex function or non-convex function is the derivative of the cost, and this is the gradient that we are talking about. Always the gradient means it is the steepest increase. It shows the steepest increase direction. Vector, gradient is a vector which shows the steepest increase. And what is gradient? Is an optimization. Optimization algorithm, we need to travel in the opposite direction of the gradient, that is steepest descent. So what are the steps in gradient optimization algorithm? First, we need to calculate the error function. Then we need to calculate the gradient of the cost function. Okay. If it is a convex, there will be a global minimum. Then we need to start with a random initial weight. From there, we have to go the opposite direction of your gradient, that is steepest descent. Optimization process is illustrated by arrows in the opposite direction of the gradient towards the minimum cost, that is from initial weights toward the minimum cost. Gradient descent algorithm have the steepest increase direction. Okay, so these are the steps in detail. First we need a initialization, second we need a gradient computation, and third we need to update the parameters. How will we update the parameters after calculating the gradient? So see, let us talk about the initialization. We will randomly choose the initial weights. Then we need to iteratively update that. For updation, we need to calculate the gradient. Then in the opposite direction of the gradient, we need to travel by taking smaller steps, that is learning rate. Then after that, after each updation, we need to update, sorry, after each steps, we need to update the parameters. Okay, the hyperparameter is the learning rate. The size of the step is determined by the learning rate, and learning rate is the hyperparameter that controls how fast our algorithm has to move. How fast or slow we move towards the optimal weight. Optimal weight means global minimum. So this is the general equation of your gradient descent algorithm. That is, we have the weight, updated weight, that is, we can say W1 or W2, and this weight is the just step ahead, that is W1. This is W2, updated weight. This is W1 minus alpha. What is alpha? Alpha is the learning rate. And del WJW. W is suffix here. Okay. Del means it is the symbol for the gradient. So del WJW is gradient of the cost function. What is the cost function here? It is represented as J of W. You can go for f of x, then del x f of x. It will comes. Okay. X is the weights there. So what is the learning rate? Learning rate is the crucial part of optimization algorithm, because the learning rate decides how well our optimization algorithm to perform for reaching at the global minimum. Okay, so if it is too small, then the algorithm will converge very slowly, that is, it will move very slowly. But if we are choosing a learning rate very high, what will happen? It will overshoot. I mean, it cannot converge to the global minimum. It is always diverged from the point. It can, I mean, it will move, it will take larger steps. So from here to here, it will go in jump. So we cannot reach at the global minimum. It may. For example, in these two figure, in the first figure, it is showing very two small learning steps. So see, it will be very time consuming and it will be complex also, because this optimization algorithm takes much time to reach at the global minimum. But what happens here? Here the learning rate is very high. So what happens from here to here? It is jumping, and here that means it is oscillating. It will be very difficult to converge here. Maybe from here to here it again overshoot. Okay, so it would be very difficult. So after, finally, what are the challenges in this optimization algorithm? That is, in this video, we are only talking about gradient descent algorithm. From this gradient descent, from all these challenges, we have put forward, or we have come forward with the RMS prop, momentum, then ADAM, ADAGRAD, all these optimizer. And now the widely used optimizer, one of the widely used optimizer is ADAM optimizer. So why all the other optimization algorithms have come forward? Because of the two challenges in gradient descent. One is choosing the correct learning rate, optimal learning rate. We have to go for an ideal learning rate according to your cost function and the updation of the weights. It should not be too large, it should not be too small. Another problem is what if your convex function is a non-convex function. Okay, there are some minimal points that we have already seen the figure, right? Convex and non-convex. So instead of reaching the global minimum, it may get trapped in the local minimum, or this we can call it as a saddle points. That the word is saddle point. Saddle points means temporary position, and from that saddle point, it will be very difficult to make it again come over to the global minimum. Okay, so these two challenges are there in the gradient descent algorithm. So that's why we have come forwarded with the other optimization algorithms. Okay, so I hope you enjoyed this video.